Hi there, my name is Dimitris Haralambidis, and in this video, we will work together some first-degree inequalities, and more precisely, the cases in which variables are found on both sides of the inequality. But before we actually start working the exercises, let me remind you of some key concepts when dealing with inequalities. Concept number one, to solve an inequality of first degree, I need to follow the exact same process I follow when solving equation of first degree. That is, separate all the variable terms from the constant terms, meaning separate all the terms that include x on one side of the inequality from everything else, which should be placed on the other side of the inequality. Then simplify like terms, and in the final part, divide both sides by the coefficient of x so that we can isolate x by itself, which this division brings us on the second concept, which is the one that states that when working with an inequality, if at some point we need to divide by something negative, we need to divide by a negative number, then and only then the order of the inequality should change. And finally, in order for my answer to be complete, I need to escort it by a visualization of my solutions. This means that I need to draw a number line on which all my answers, all my solutions are clearly shown. With that said, let's start working with exercise number one. 3x plus 5 is greater or equal than 2x. As you should all know by now, the way I'm solving these cases is by first visualizing an imaginary auxiliary line, a line that will help us, that separates the left-hand side of the inequality from the right-hand side. Then I will color with blue all constant terms and with yellow all the variable terms. Now, my key plan is to separate yellow from blue terms. To do that, I will bring all yellow ones at the left. So 3x was already there. 2x should move from the right side to the left, which will make it change its sign. Greater or equal than -5. And why is that -5? Because originally it was placed at the left side. Now I have to move it to the right. Its sign should change. Then I simplify the like terms. 3x minus 2x is obviously equal to 1x, which is greater or equal than -5. Then, not that here it's needed, but let's follow the process. We divide everything by the coefficient of x, which is 1. I divide by something positive, so the order of the inequality remains. -5/1, so overall x is greater or equal than -5. Am I done? No, I still need to draw a number line, place 0 somewhere in the middle, -5 somewhere at the left, greater or equal than. So greater means from -5 to the right. It says is equal to that, so I should totally color this circle. Example number 2. 2x plus 7 smaller or equal than 5x minus 6. Again, I will begin by visualizing a line that separates the left-hand side from the right-hand side. Then I will color all the variable parts, 2x and 5x, with yellow, and all the constants, the ones that do not have any x, with blue. Again, my plan is to separate these two colors. Let's bring all yellow at the left. 2x was already there, so nothing will change, 2x. 5x was at the right, now I need to move it at the left, so I will change its sign, -5x, smaller or equal than. -7, because it was to the left, now it will turn to the right, so its sign will change. -7 minus 6. 2x minus 5x, it's equal to -3x. Smaller or equal, -7 minus 6, it should be -13. And then remember that we always need to solve for x, which means that I have to isolate x, which also means that we need to get rid of -3. How can I get rid of something which is being multiplied? I have to divide by that number. So I'll divide both sides by -3. But be careful, we are working with an inequality. Every time in an inequality we have to divide by something negative, the order should change. So the order from being smaller or equal than, it will turn to greater or equal than. The -3's are cancelled out. X should be greater or equal than 13/3. And of course, don't forget the number line, 0 somewhere in the middle. 13/3 is a positive number, so we don't need to keep an exact scale. 13/3 should be somewhere there. Greater or equal than that means that it extends to the right. It includes the equal, so I should totally save it. And let's do one final example. -3x minus 9 smaller than 10x plus 100. Again, I'll begin by drawing this imaginary line. Then I will color all constant terms, meaning those that do not include any x, by blue, and then all the constant ones by yellow. I need to bring all yellow ones at the left. -3x was already there, so nothing changes. 10x was at the right, now it will move at the left, so it's gonna be -10x, smaller than. -9 was at the left, now it should move to the right, it's gonna be +9 plus 100. -3 minus 10, it's -13x, smaller than 109. I need to get rid of -13. To do so, I will divide both sides by -13. Since I divided both sides by something negative, the order should change. So from being smaller than something, it will now turn to being greater. The -13's are cancelled out, so we're left with x, which is what we wanted. X is greater than, we don't care about the actual number, it's just this, -109/13. I will carefully draw a number line, 0 somewhere in the middle. Remember that it's not about the scaling, it's just a visualization. So -109/13 is certainly a negative number. So let's place it at the left of 0. We want it to be greater. We want the solutions to be greater than that. So they extend to the right. Not any equal is included, so I will not fully color that cell. And that was all. I hope this video helped you solve some of any possible issues. In case it didn't, and in case you still have questions, please don't be shy. Leave them below in the comment section. As always, thank you for your time and thank you for watching.